a proof. First of all, you write a conjecture that needs to be proven, and if they're asking you to write a proof, they will say, here is some given information, prove this. A lot of times they will tell you what they want you to prove. Okay, what the next step is to kind of draw a diagram, okay, of where you're starting and where you need to end up. You state the given information and mark it on the diagram. Now notice the only thing we put on the diagram is the given information. Okay? State we do not put what we want to prove on the diagram. Otherwise it makes it a wrong diagram. You can't start with what you wanted to prove. Next you state the conclusion. Okay? How would I get there? And then you plan out how you're going to do this, okay? So you look at what they want you to prove, draw it out in a picture, think about the properties you know, and come up with a plan, okay? So here we're kind of coming up with a plan. Here we put it together and we actually go ahead and write a proof. So this is the order for our writing a proof. Now let's do it here as an example, okay? So use the given plan to write a 2-column proof. So here is what they started with. They said, given that angle 1 and angle 2 are complementary, angle 2 and angle 3 are complementary, prove angle 1 is congruent to angle 3. This is our congruent complements theorem. They want us to show what the proof would be. They gave us a picture over here, okay, of angles 1, 2, and 3. And they came up with a plan, okay? They said, okay, as we're thinking through this, the measures of complementary angles add to be 90 by definition. So we know angle 1 plus angle 2 is 90, angle 2 plus angle 3 is 90. Then they said maybe we could substitute to show that they're equal. So if both of these add to equal 90, then 1 plus 2 has to equal 2 plus 3, the angles. Then they suggest using the subtraction property to end up with just the 1 and the 3. And I'm going to show you what this proof looks like. Now, when you write a 2-column proof, on the left you'll have your statements. That's your logic as you work through it. And on the right, you have to justify each of those steps. You have to back it up with a property. So let's take a look at this one. They gave us a plan. So their plan was, well, complementary angles add to be 90. We have to start with the given information. So that was our step 1. Step 1 is that, well, 1 and 2 are complementary, 2 and 3 are complementary. Our reason for that is given. We would not know that if they had not told us. Our only reason for knowing that is that it was part of the given information. So your reason for step 1 is that it was given. As we go to step 2, we're following their plan. They said, well, what does complementary mean? It means they add to be 90 degrees. So angle 1 plus angle 2 was 90, and angle 2 plus angle 3 was 90, because angle 1 and angle 2 are complementary. That gives us this. Angle 2 and angle 3 are complementary. That gives us this. What is our reason? Why can we say that? Our reason, that's the definition of complementary. The definition of complementary is that the two angles add to equal 90. Hey, we're continuing through the plan. We get down to step 3. Okay, well, we notice that these both equal 90. If they're both equal to 90, then they would have to equal each other, right? Because this is supposed to be 90, and this is supposed to be 90. 90 is equal to 90. That is called substitution. We knew two things were the same. So basically what we did is we said, well, angle 2 plus angle 3 is 90, okay? And I know 90 is the same as angle 1 plus angle 2. I can replace the 90 with what it's equal to. So that gave us angle 1 plus angle 2 on one side, and instead of 90 over here, we had an angle 2 plus angle 3. That is called substitution. As we continue through the proof, we get measure of angle 2 equals the measure of angle 2. How do we know that? Well, it seems obvious. Angle 2 is going to be equal to itself. It has a specific name for the property that everything is equal to itself. is called the reflexive property. And again, that's one you'll want to have in your notes. So when you go back and when you're like, oh, what's that property where something's equal to itself? You'll be able to look and say, okay, that's reflexive. Why did we do that? We did that because we needed to subtract the same number from both sides. And so now that we know that angle 2 is equal to angle 2, we know if we subtract it from both sides, they will cancel each other out and give us just this, that angle 1 is equal to angle 3. What did we use? We used the subtraction property of equality. It tells us we can subtract the same number from both sides of an equation, and that is okay. It's a legal thing to do. That's the subtraction property of equality. So that was our justification here. Okay. And finally, we're saying, and since 1 and 3 are equal, that means they are congruent angles. And our reasoning for that is that that's the definition of congruent. If two things are equal in measure, they're congruent angles. And if two things are congruent, that means their measure is equal. Why did we have to take this step? Why couldn't we just stop at 1 equals 3? Well, that's not what they wanted us to prove. They wanted us to prove that angle 1 was congruent to angle 3. So we had to take that last step and convert this into saying congruent instead of just the measures are equal. But again, our reason, anytime you go from two things being equal to them being congruent, your reason is that that's the definition of congruent. All right, let's go through another proof. Okay, so here's what the person was given. They were given that angle 1 and angle 2 are a linear pair. So you would want to go, okay, what does linear pair mean? It means two angles that form a straight line, which we have in our picture here. Okay, angle 1 plus angle 2, together they make a straight line. We're supposed to prove that 1 and 2 are supplementary, which means 1 and 2 add to be 180. Okay, so we're trying to get that angle 1 plus angle 2 equal 180. This is a proof of the linear pair theorem. How did they get that? Well, they start with, once again, the given information. Angle 1 and angle 2 are a linear pair. That was given to them. BA and BC form a line, so that's where our diagram comes into play. So we can go, well, what's BC and BA? Well, that's the definition of a linear pair. Okay, a linear pair are two angles whose rays are opposite rays, whose sides are opposite rays. Number 3, the measure of angle ABC is 180 degrees. How did we know that this flat angle is 180? That's just the definition of a straight line or a straight angle. So that was our reason here. This piece is missing. What do we do next? Next, they have the angle addition postulate. Now, the angle addition postulate is when you add two angles to equal a bigger angle. So notice if we add angle 1 and angle 2, we get angle ABC. So in here, our step would have been, if we add angle 1 and the measure of angle 2, we get the measure of angle ABC. Next, it says they're using substitution with steps 3 and 4. They put that in there to kind of give us a hint of where we're going and help whoever's looking at this proof. Well, ABC is 180 degrees, and here we have an ABC. Substitution means we can replace the ABC with what it's equal to, which happens to be 180. So we have measure of angle 1 plus measure of angle 2 equals 180. That's the substitution property. We replaced angle ABC with 180 because up here we knew that it was equal to it. And finally, to our last step, angle 1 and angle 2 are supplementary. How do we know they're supplementary? Well, the definition of supplementary is two angles that add to be 180. So our reason here is definition of supplementary. Okay, in the future, we can just say if two angles are a linear pair that they're supplementary because we've now proven that theorem. And again, this was our linear pair theorem. If you know it's a linear pair, then it's supplementary. And forming theorems makes it so we don't have to go through all of these steps again if we want to show two angles are supplementary. Okay, and here is the completed proof for you here, if you want to take a screenshot or keep that for your notes. Okay, so notice the empty spots they had here and here I've filled in. So this is what it would look like all nice and cleaned up. All right, here's another one. We want to fill in the blank, and we're going to do the proof that congruent supplements theorem. And again, what I'm doing here is just giving you examples of proofs to help you see kind of how proofs flow and how we come up with a result. Here we are given that 1 and 2 are supplementary, 2 and 3 are supplementary. We want to prove 1 and 3 are congruent. Now, if you went through the proof of congruent complements theorem, this is going to be very much the same. We have some missing parts. Line 1 is missing, and it says our reason is given. Line 1 almost always is your given information. Okay, so here we would put in the angle 1 and angle 2 are supplementary, angle 2 and angle 3 are supplementary. From there we can say angle 1 plus angle 2 is 180, angle 2 plus angle 3 is 180, because that's the definition of supplementary. It means that if they're supplementary, they add to be 180. I'm going to go ahead and go to the next slide, which has, I've filled in the missing pieces. Okay, so notice I filled in this spot here, and that was our given. We could go to the next step. Again, we can say 1 and 2 add to be 180 because that's what supplementary means. 2 and 3 add to be 180 because that's what supplementary means. Okay, we set those two equal to one another. What did we use there? We used substitution. Okay, we said, well, if 1 plus 2 is 180 and 2 plus 3 is 180, can't we replace this 180 with an angle 2 plus angle 3? Yes, we can, and that's what we did right here. Next, angle 2 is equal to angle 2. That's the reflexive property. Everything is equal to itself. And we used that then so that we could subtract angle 2 from both sides, because the subtraction property says if you subtract the same thing from both sides of an equation, that's okay. They would cancel and just leave us with angle 1 equals angle 3. That is the, again, subtraction property of equality. We got that from subtracting the measure of angle 2 from both sides of that equation. And finally, we can say that angle 1 is congruent to angle 3. Again, the reason for that, anytime you go from two things being equal to saying they're congruent, that's the definition, that's what DEF stands for, of congruent angles. Okay, so we go from measure of angle 1 equaling measure of angle 3. That means angle 1 and angle 3 must be congruent.